This solid model is going to be on chapter 6, exercise 2. And I am creating this for solid model for engineering 151 at San Diego Mesa College, trying to help the students to be able to follow the lecture, and if they're falling behind, they can watch the videos and be able to complete their assignments. Okay, let's get it started on this exercise. We're going to go to new, and this is chapter 6 dash exercise 2, and we say okay. So we're going to have this planes, and we're going to activate the tag name. Okay, so we have the top, front, and right side view. For this assignment, we're going to use the sketching plane, which will be the front view, extrude, placement, define, front, and the reference and orientation is going to be right. Okay, let's click on the sketch view, and we're going to go sketch view, and I'm going to remove the filter and place the center line on a vertical axis, and if you want, you can just place the center line on the horizontal axis. Okay, first I'm going to create a rectangle which is symmetrical with respect to y-axis, and the dimension for the width is going to be 90. Okay, 90, enter, and the height is going to be 24. Okay, or maybe I'm going to just use this side. I'm going to say 24. Okay, 24. All right, great. Then I'm going to create a circle at a dead center here, and that will be a diameter of 45. Okay, 45. Okay, great. And the distance from the top of this rectangle to the center of this circle, it should be 60. Okay, according to the given dimension or a specification. So this is what we have. All right, very good. And let me just turn off the model tree. So I'm going to connect this corner and all the way tangent. Make sure that the point of tangency is going to show that. All right, so since point of tangency is clearly specified, and now that's what we wanted. Okay, point of tangency. So, and then the next one on the other side, we're going to do the same thing. We're going to connect from this corner to, as soon as we move the line closer to the circle, you can see that this is the line that is going to be tangent. Okay, tangent, and then middle click to terminate the command that we invoked. Now we need to remove some unwanted lines like this and this portion of the circle. Just watch for the portion of the circle that needs to be removed. Okay, this is the leftover, and that's where it's going to cause problem. Okay, make sure that you remove it and you trim this leftover piece. So now we have the what do we call that? When there is a shade, that means your sketch is complete, and at that this for the base feature, this is good enough. So we're going to extrude that. Okay, and the amount of extrusion is going to be 12. So either you can click on this number here or right here is the same thing. Okay, you're going to say 12. So and that's the extrusion. Okay, 12. And then we're going to say we're happy with that. And next we're going to extrude, placement, define. We're going to click on this surface here, sketch view. Next we're going to create a circle which is going to coincide. Before we do that, I forgot to mention something. So you right click and you'll put the reference. You're going to define this curve. By defining that curve, that means you put a reference reference here, so it will be easier to when you create a circle. See it, this is, let me just turn off the shade, and we have a no hidden. See that? And the snap, the cursor is going to be snap to the center of the circle. Okay, then when you stretch that, watch this very carefully. As soon as you get close to the existing curve, it's gonna say r equal r. Okay, see that? R. So watch for that. Don't go over it. Okay, just as soon as you see that, and then you say I'm happy. So R1 equals R1. Excellent. So let's just put the shade back so we know where we are at, and then we say extrude. The amount of extrusion, it should be, because it should start from the back, okay? And on the assignment it says the amount of extrusion is 30, but actually 30 is from the back, okay? From this side, from the back side all the way is 30. But from this surface, the amount of extrusion is nothing but just 30 minus 12, because the thickness is 12. We're going to say 30 minus 12, and CREO parametric does the calculations also, so you can do the operation like adding and subtracting. So it's 18. So the amount of extrusion is going to be 18 units from this surface, okay? From this surface right there. And then we're going to say we're happy with this, and we're going to extrude that. So that's what we have. Next, we're going to do another extrusion. And if you look at the model tree so far, we have created the base feature extrude number 1 and second feature extrude number 2. So we are happy with those two so far. Next, we're going to create a circle that is going to be through, or a hole that is going to go through this material. So we go extrude, placement, define, and then you click on the surface, sketch, and you don't have to make it a sketch view. You can, it's very simple. You just click on the center point, or X and Y axis, so that's here, and we're going to give it dimension of 24. The diameter is 24. Enter. Now we're going to check, and we reverse the arrow so that we want to poke the hole through this cylinder and the plate. So we're going to go in the opposite direction, or we're going to go all the way through, okay? And that is the extrude to intersect with all surfaces. Okay, perfect. See that? It's going to go through the materials, and we are happy. So far, so good. Okay, so that's what we have. And then we'll go check. Next, we're going to create a rib on this, in the mid plane of this face, okay? But let's just turn on the plane display, and then this is the plane that we wanted to use. Let's just select that. So all right, so you can see that you rotate them, and then you want to ensure that that plane is the one that we wanted to place the rib. Otherwise it's not going to work, okay? For rib profile to work in CREO parametric, you must use a plane. So that plane, if it's not there, you have to create a datum plane. Okay, let me do this. We go to rib profile, okay? Just do not use the trajectory rib, just use profile rib. And then since we have already selected, and if you click on sketch view, it's going to show you the face, okay? The right face. That's the right side plane, okay? This is the right, and this is the front, and this is the top. So if I go to a sketch view, so it's going to give us that. Let's just turn off the plane so it's easier to see it. And in order to define the edge that we want the rib to connect to, these two edges, I will, instead of using references, because references may not work, so use project, create entities by projection. So I'm going to just use that line, and then I'm going to use that. Then I'm going to create a line that is snapped to this point and is snapped to that point corner. And then I'm going to remove, okay? Do not forget to remove this temporary line. All right, and then this temporary line, you have to remove it. And now you rotate your solid model just always it's a good idea to hold the middle mouse button and rotate them, and make sure that is what you're doing is going to be visible. Okay, it has to be visible. So when you just look at it this way, you might say, what am I doing here? So this way is going to make it to ensure that you are connecting that line to the top, to this top edge of this line and the top edge of this cylinder. See that from this point to that point. So that's all you need to do. You don't need to create a rectangle. Okay, for CREO parametric, using the rib profile, this is really all we need to do. Okay, so then we're going to click check, and now you can see that there is a random thickness for the rib, and we need a thickness of 8. Okay, I'm going to enter 8. So that's our rib. Rib is just this is going to support this structure. Okay, so this as a support, so we have everything is nicely done. So I'm going to say we are happy with that and nicely placed on that. If you look at the right side view, see this is how it's going to orient, the orientation of this. And if I wanted to look at the front view, because someone in the class asked me, how do I know which plane to place this? You just start, I think I look at, for every solid model is a bit different. You have to make a decision, because this software is for designers. It's created for designers. So as a designer, you should be able to decide which view to begin with. We call it the sketching plane. Should be we should start our base feature on that plane, and that we call it a sketching plane, or base feature will be placed in frontal plane, or profile plane, which is the right plane, or horizontal plane, which we call it the top plane. Okay, so those are the 3 planes of projection in orthographics, even, or three-dimensional solid modeling. We can say that we have 3 planes of projection, and we have 3 principal views. The 3 principal views are called the front, the right, and the top. Okay, because again, someone asked me in class, how do you know which view we're looking at? The standard view, according to US system of drafting or mechanical drawing, we have to just look at the face. This is the isometric. Okay, that's our isometric. And if you look at the face, this face, we call it the frontal plane or front view. And then if you tilt it like this, that will be the top view. And then if you look at the side, that's the side view. Those are the 3 principal views, we call it. When we create the blueprints or layout, 2D layout, you will see that what we're talking about. Okay, the 3 views. Some people like to use the left side, which is in most cases left side view. It might be less has a more invisible line than visible line. The recommendation is that pick the 2 views or 3 views as needed to show the shape of an object with a maximum clarity. Okay, maximum clarity. That's the name of the game in mechanical drafting, because you don't want your part to be created in an oblique angle. So this look oblique angle, that's not pretty, correct? Because this piece is not visible. This piece is not visible. So that is my advice always in classes, to just make sure that you look at all the views. Like you go here and look at this views orientation. Okay, see that you have the 6 views in orthographic projection. Only we need 3 views to sometimes 2 views are sufficient to show or to describe the shape of an object. It depends on whether it is an object that we're creating. It has more cylindrical shape, which is and the projection is going to be the same either in the right side view or in the top view. So we're going to decide whether to show but the front view is a must. Okay, you must show the front view, and then the right side view and top view, you have to make a decision. Okay, which do you need all 3 views, or you only need 2 views? You make that decision, And then for beginners, you just look at the book assignment to see if they are showing, two views, make sure, and then you just, look at it and then be a judge, okay? You judge yourself. Say, oh, okay, the reason is because there's the third view, if I add them, is not going to add any more information to the solid models. It doesn't describe the solid model with, with the clarity or more clarity. All right, so when I say top, see that it's going to show top. If I just click on the front view, that's my front view. That's a nice orientation, okay? And then the right. And then if I want to click on the left, see it? It's going to show the left. And then if I want to show the bottom view, which is the mirror image of the top view, the bottom view, so that's the bottom view. And we're not interested on that, okay? We're not interested. So let me just show you how to create a hole on this face, okay? We're going to go extrude, placement, define this face here. We're going to sketch view. And then let me do this something called just convert this to no hidden so you can see the clear surface here and instead of showing the shade. So for being able to see it, the surface with more clarity, we're gonna just click on this circle here, just drop it anywhere because we have the dimension. We're gonna define the dead center by dimension. So this is a parametric software, means dimension driven. Everything is decided based on the dimension, okay? So you see that I needed to place the references on this edge and this edge. So when we do that, then when I say solve, you can see that all this, the random, see that if you don't place the reference line on the edges that you want to take your dimension with respect to this axis, this line, this edge, and this edge, and then since it was not defined, automatically looked for a reference right there. That's a blue dash line, and this blue dash. See that it just moved. It's just taking the information from the center to this dash line and to this dash line. Now, as soon as I say solve, okay, on this window, see that it's gonna jump. It says, wait a minute, you are telling, because you're dictating as a operator, as a designer, you're telling me that I must just give you the dimension based on, that's a random dimension, that's a weak dimension, and we are not interested on weak dimension. This is a good thing about CREO parametric. It gives you some dimension which is not the actual dimension. So you need to convert, you need to enter, you need to enter the dimension that it's supposed to be, or actual dimension that that means we're converting the weak dimension to a strong dimension. In SolidWorks, it's the same thing, but they don't, in the SolidWorks, they don't really show any numbers or dimension. They just tell you that your sketch is not fully defined and you have to give enough relations or constraint. You have to impose constraint, or you have to just, in SolidWorks, the constraint, they call it relation, okay? Like adding dimension, necessary dimension, or using tangent, or symmetric, or coincident, and so on, okay? Just let's continue. All right, I'm going to give the dimension here called 18. All right, 18, and then I'm going to give the dimension also 18 by 18. So that's how we defined the center of this circle. With respect to this edge is 18, with respect to the top edge is 18. So we are saying that the dead center is there, okay? And then I need to give a diameter of this circle, which is 12. Okay, we're going to enter 12. So we are happy. We know that now we have the hole is located with respect to this edge here. Let me see if I can move this a little bit, right there, and I can move this here so you can see that a little bit better. Okay, so if I just look at that, like in algebra, okay, in an algebra class, in a Cartesian coordinate system, if you wanted to locate a point in a quadrant 1 or 2 or 3 or 4, we just said, okay, we have a coordinate called or order pair called x and y component. So x and y component will dictate where the center of, or a point or center of a circle is located. Okay, all right, so let's just convert this to shading, and we're going to say extrude. Okay, we're going to extrude that. So the extrusion, automatically they give you that coming out of the face, this surface here. So we need to reverse the arrow. Now it's going to poke the hole through this material, and then we don't need to give any numbers, any dimension. All we have to click on called extrude to intersect with all surface. Okay, all right, so beautiful, everything is nicely done. And now we're going to go to finalize. That means build feature. Okay, this is called build feature, and we're going to just finalize it. Okay, now the hole is now we don't want to just spend time and put the hole again, drill a hole on this side and give dimension. Since it's symmetrical with respect to the plane, the mid plane of this, I'm going to turn the plane on again, and you can see that while this hole is highlighted, I'm going to click on, I'm going to go to mirror. I'm going to mirror this with respect to what? It says, what's your reference? I said, this is my reference. Okay. And then as soon as I select the reference, all I have to do is click on a check mark, the green check mark. It's going to place the hole on the other side of this reference plane. All right, so that's easy to do. Okay, easy to do. So I'm happy with that. Okay, and then if you wanted to auto scale it and then maybe move them around a little bit. Okay, sure. And let me just turn off the display again. Next, we wanted to put a round on this edge, okay, on that edge. So I'm going to click on round, and the radius of that round, it should be, let's see, the radius is 10. I prefer to place the fillets and round on the solid model than in the sketch, okay? And that is, I think that's preferable than just creating the fillet and round on the sketch view. Okay, all right, so let me click on this edge, and you can see that I put a round on that corner with a radius of 10, and click on that edge also. So both edges are now defined, and then we're going to finalize this. Okay, all right, beautiful. Now if you want to render it with some kind of color, these are the beautiful colors. Look at that. So I'm going to use, I don't know, well, pick a color, just a cosmetic. Okay, so I'm going to just click on that surface. I say I'm happy with that front, and then I'm going to use blue on that face, and then say okay. And then we can just use maybe different color, like yellowish color. So we're going to go to here and then control. Let's see if we can just do that. Okay, so that's that one. And let me see if I can define maybe by color and this rib. Okay, let's see the rib profile. And let me hold the control down and click on this face, and then click on this face here, and then say okay. So that's our feature called a rib. There are three features in mechanical drawing or drafting. We call it rib, spokes, and webs. Those are the three features that are used to reinforce the solid models. So this way we can just have a rectangular support or spokes or wheels. We call it the spokes, and then the web. And those are the three features in mechanical drafting that we need to just be able to understand it. So if someone has a background in mechanical drafting or basic skills of drafting, it has been defined in a textbook called Engineering Graphics Communication, which unfortunately nowadays we don't teach that anymore in colleges and universities. We just go directly to CAD, which is since I come from the background of many years of teaching mechanical drawing, hands-on drafting, it was really vitals or important aspect of drafting is to be able to communicate with your sketch or with your drawing with people in the machine shops, and the people are going to use tools to make these solid or parts for you. So anyway, I'm hoping that every time I teach this class, I try to explain the language of engineering graphics communication. I try my best within given time to be able to transfer that information or knowledge to my students. So, all right. Hope you had fun, and I had fun creating the solid models, and hope you're gonna enjoy watching this. And I try my best to explain this in the best clear possible way. All right. I think I'm done.